Welcome to this video on recurring decimals and fractions. Now, this is the kind of question where you're given a recurring decimal and you've got to convert it into a fraction. Now, they may ask you to, they may give you the answer like they've done here and ask you to prove it. They may ask you just to do it. But in either case, you've got to understand what the recurring decimal actually means. And you always have to introduce some algebra into this kind of problem. And this is the process you should follow. So let's do the first one here. We start by writing down that x is the recurring decimal 0.57, but we write it literally as a continuous decimal. So 0.5777 ... just to show that it goes on forever with the 7 repeating, but not the 5. That's what that little dot means there. And then just go through the steps, multiplying by 10 each time. So I'm now going to times that by 10 and do 10x, okay? And work that out. And it simply means shifting the digits along so that the decimal point is in a relatively different place. So it's 5.777, okay? And then I do 100x. Now, obviously, you don't just keep going forever. You stop when something happens. And what you're looking for is when you notice the part to the right of the decimal point equaling something you've previously done. So I'm about to come across that now in this one. So timesing the last one by 10 would give me 57.77 and so on. All right. Now, if you look at the previous one and this one I've just written down, the decimal part is 0.777 in both of them. Okay, so I stop there and I link those two together. Okay, I normally show a sort of a link like this when I do it. Okay, and if I subtract the second row from the third row, that will eliminate the decimal part completely, because 0.777 minus 0.777 is 0, all right? And I must do the same to the left-hand side. So 100x take away 10x gives me 90x, okay? And on the other side, 57.777 minus 5.777 will just give me 52. Exactly. So there's no recurring parts to deal with anymore. Now there's a simple equation to solve. If 90x equals 52, then it follows that if you divide both sides by 90, x must equal 52 over 90. Okay? And all you have to do now is reduce that fraction, if you can, into simplest form. Well, that's what it says, and it does because it's got an even number on the top and bottom. So we know at least it divides by 2, and it does to give us 26 over 45. Okay, and that is as far as it goes. There's no common factor of 26 and 45. So that's it in simplest form. All right. So that was a relatively straightforward one. The next one is a little bit more tricky. Okay, so question 2. We'll need a bit more room for this one, as you'll see why now. Okay, so I'll start here. Okay, but we do begin in the same way, but we need to understand what this 315 with the dots in that position mean. So let's have a look. It means this. X on its own is equal to 0.315 and so on. Okay, and I could go on, but that's more than enough to show that you understand what's happening there. So it's the 315 that repeats, the group of digits between the first and last dots. Okay, And then you have 10x, and you do the same as we did before. So 10 times x is just going to be 3.15. and so on. Okay, and then we do 100x. Okay, and 100x is going to be 31.53, and still we don't have 53153 and so on, but we don't have anything matching at the moment. So after this first point we have 315, the second row we have 153, and the third row we have 531. None of them match, but in the fourth row we will find that something matches a previous row. And here we go. 1000x will be 315.315 and so on. Okay, and if you look now at this one and this one, the first and last row in fact, so if we link those two together, that row and that row, you can see that they both contain 0.315 and 0.315. Okay, so if I do 1000x, take away x, that's going to give me something that doesn't have a recurring part. Well, 1000 take away 1 is 999, so 999x, okay, is equal to 315.315 minus 0.315, which is exactly 315. Okay, well, if I divide both sides by 999, then I get that x equals 315, okay, over 999. Now that isn't the answer given, but it will be in a moment because we have to simplify this. Okay, so what we're going to do is notice, hopefully, that the bottom divides by 9. Well, that's pretty obvious. Maybe not so obvious for the numerator, but it does divide by 9 because if you add the digits of a number together and it gives you a multiple of 9, then the whole number divides by 9. 3 plus 1 plus 5 is 9. So that means 315 divides by 9. And a quick calculation shows that 11 nines are 99, so 33 nines are 297, plus you've got another 18, which is another 2 nines. So you get 33 plus 2, which is 35. Okay, so 9 goes into 315 35 times, and obviously it goes into here 111 times, and that is the answer that you had to prove. Okay, so we've done the second question. Now the third one, really fascinating actually, this one, because people will say 0.999 recurring is as very, very close to 1. Well, actually it is 1. It's exactly 1. And people really struggle with that idea, but it is true, and it's so easy to prove. We're going to do exactly what we just did for the other two questions. So just watch this. So for question 3, okay, x equals 0.999, etc. Okay, and therefore 10x must equal 9.999. And so on. Okay, well, you've got the link you want because they both have a decimal part of 0.999. So we do the same thing. We subtract. 10x take away x is 9x. Okay. And 9.999 take away 0.999 is just 9. Well, if 9x equals 9, then quite simply x must be 1. Or if you like, x equals 9 over 9. Okay, following exactly the same process as we did up here, which is equal to 1. So you've actually proved algebraically that 0.999 recurring is the same as 1. Okay, so I hope that was helpful. Make sure you learn what the recurring decimal looks like and what the dots above the digits actually mean in practice. Okay, take care.